taking a look at example 3, we want to solve this inequality that says x squared plus 5x plus 8 is less than 0. So I go to solve the related quadratic equation. So I go x squared plus 5x plus 8 equals 0. Notice that's not factorable, is it? If I do b squared minus 4ac, I get 25 minus 4 times 8. I get a negative. This answer is going to be complex. So let's take a look at the graph of this. And notice when I look at the graph of this graph is never below 0, is it? So there are no solutions for x that will make this true. And the same way with example 4, only backwards. On example 4, every value of x I put in is above the x-axis. So this would be all solutions. Or infinite solutions. I like to say infinite rather than all. So now we'll go infinite solutions. Now, if we take a look at example 5, this one's a little different too. First off, I can graph my related equation. So if I can factor my related equation. So I get x squared minus 10x plus 25 equals 0. So I get x minus 5 squared equals 0. So x equals 5. Now, what's important about this is because there's one double root. So when you make your sign chart, you got to be kind of careful there. When am I going to be bigger than 0? Well, I'm equal to 0 when x is 5. And notice when I put a number in bigger than 5, let's put in 0 for x. So let's test x equals 0. So then I'm going to have 0 minus 0 plus 25. So that's true, isn't it? So it's true when x equals 0. And then how about if I go to the right? Let's try x equals 10. So 10 squared is 100, minus 10 times 10 is 100 again, plus 25. Notice this one kind of violates my rule. That's also true. So what happens is it's always greater than 0 except when x is 5. So our solution is going to go from negative infinity to 5, and from 5 to positive infinity. And if I look at the graph of this, I think the graph makes a lot more sense when we look at the graph here. Here's my graph. Notice it equals 5 just at one point. Otherwise, it's always bigger than 5. And then if I look at example 6, it's kind of backwards. It's less than or equal to 0. Well, the only time it equals 0, we know from we just did it, was when x equals 5. We do not have an inequality here. You have one solution because any other times it's greater than 0. So it's never less than 0, and it's equal to 0 when x is 5. So there's our solution. We call those kind of weird, these last four, they're kind of weird solutions, aren't they? Are unique.